Good afternoon, everybody. Okay. Okay. Can you hear me and see my presentation?
Yes, well.
Okay, perfect. So I will tell you very briefly what we, and for we I mean our Institute of CNR in Milano. The name of our institute is SCITEC. What we have done with students, and I will divide my presentation in two periods, before the pandemics and after, because this event of course, affected our activities. So pre-pandemic activities, we have implemented some hands-on stages in our laboratories, which are connected with those of the University of Milan, the Department of Chemistry. And we have implemented a couple of workshops in presence. During the pandemics, and so during the last 2 years of the project, we had to rely just on remote mode activities. And here you can see a typical image of the many meetings all of us have done in the last 2 years. We had an internal internship with the students, Andrea Sima from Romania. She had a period of activities in our lab in Milano in collaboration with HIDEP. And she is planned to speak later this afternoon. The topic of her stage was the design of electrolytic cells, electrolyzers and hydrogen refueling stations. I haven't seen her connected till now, but I hope that she will connect later. So she was the first. And then we had a domestic internship, students of 17 years coming from a second grade school, Facchinetti in Italy. And in particularly, he worked in one of the lab of our institute, the high resolution transmission electron microscopy laboratory. And his activities had as a main topic the synthesis and purification of fluorescent organometallic compounds. Then in the years 2018 and 2019, we had 8 students, not all together, separated in 2 groups, who worked with us and had the possibilities to use our instruments, our scientific devices, for 3 weeks in September, during the month of September, before the beginning of the school. And in particularly, they worked in our Smart MATLAB Center, which is a multifunctional joint laboratory and training center for the characterization and pre-applicative test of smart materials in Milano, and also in our catalysis laboratory with Vladimiro and Filippo as tutors. Because of course, all of the students had some tutors among us. For the event, again in the period pre-pandemics, we had a 1 day of event called the Tech Day in Locarno in Switzerland. And we went there for lessons and also to play with this game regarding raw materials in the loop. As said before by Vladimiro, we had a workshop dedicated to teachers. In October 2019, we had more or less 30 teachers from schools, and the topics, the title of this workshop was the 3R approach, sorry. Okay, I'm going to conclude my brief presentation. During the last year, we had just the remote mode international internship. We had a team of students from Romania and Bosnia Herzegovina, and Marin, who will make his presentation just after me, after myself. Tudor Gabriel Muchoy and Alexander Petrasevich, and we planned with them a topic on which they worked and make some researchers, but we met just by Teams or Zoom. So I now leave the floor, if Karin agreed, to Andrei Marin, the students from Tudor Vianu National College of Computer Science, who will talk about a brief study of iron oxide nanocubes and applications in treatment of cancer. And I thank you for your attention.
Thank you, Raffaella.
Okay.
Thank you.
Hello, Marin.
Hello. Do you see my screen?
Yes, we see.
Yes, we can. Okay, perfect. Now it's perfect.
Perfect, yeah.
Okay. This was our study related with iron oxide nanocubes and their applications in treatment of cancer. Before actually starting to work on this presentation on our project, which was submitted in PDF format, somehow resembling a scientific article, we received a lot of guidance, and we had several courses from researchers, and this was very interesting and unique experience, at least for me. Now, as far as I know, my colleague Alexander, he joined us as well, if you are here.
Yes, I'm here.
Okay, so I think you can start presenting the first part of our project.
Okay. Today in modern medicine, there is a terrible disease for all the human races called cancer. It is known that even modern medicine has no cure for the complete destruction of cancer. The most common methods for treating cancer and also to help people to live longer and better are three very known methods for all of us. That's surgery, radiotherapy, and chemotherapy. But there is one problem because all of these methods, while trying to destroy cancer cells in our organs, they usually affect some other tissues and organs. So that make a big problem to our organs and our health. Alternative also have an alternative method of cancer treatment that is rise cells temperature to 42 degrees Celsius. I mean, we need to cause a hyperthermia. Because at this temperature, cancer cells are induced while healthy cells continue to live. But there is also a problem because we can't the full destruction of cancer. So to cause hyperthermia, we need to use, as we chose, metallic nanoparticles. General mechanism for this method is when an alternating external stimulus is applied to the nanoparticles system. It started to mechanical oscillations occur. These oscillations should increase the medium's thermal agitation and hence its temperature. Also, we need to meet several factors to achieve this thermal effect. And there are, as you can see, first is a nanoparticle, material shape and size, coating and intensity, which means frequency of applied external field. Aim of this project, to finish this study is studying 19 nanometer iron oxide nanotubes, which we choose to work on, with C-peptide coating under AC magnetic stimulation. To complete this project, we need to go through three very important steps. As you can see here on your screens, there are synthesis, characterization, and analysis. Synthesis is for first, we could use a hydrothermal method, which will allow us to regulate shape and size of nanoparticles. This is a very important part for startup project. With this, we will be able to control which nanoparticle will go to the organ of our choice. Reaction conditions, on a pH value or reactant ratio, for example, influence the final product. So if we continue with working in solution, we can avoid unexpected reaction. So that could help us to fight against cancer even well as now. Coating, which is equal with C-peptide, will enable two options. First is to ensure a specific targeting of the alpha V beta free reach tumor cells, and the second are that coating can, our nanoparticles can resist for several months in solution. So that could be one of the most important parts for this. Although coating synthesis will present like a conjugating with peptide through many reactions. Next, there are three required materials. That's it: ferrous fluoride, tetrahydrate, ferric chloride, and last is sodium hydroxide. Optimal temperature for synthesis. Temperature which is most common to work on synthesis is somewhere about 100 degrees Celsius. On the end, we have two synthesis procedure. That is, first one is a mechanical agitation of the reaction environment through stirring. That would be followed by a natural cooling of the solution, but we will of course use ours. Second is to precipitate appears, which is separated through centrifugation and later washed in order to eliminate the impurities. Now my colleague will continue with the next two steps.
Sure. The difficulty we encounter when we try to characterize these nanoparticles is that we can't use optical microscopy because of their small size. And we research about other techniques, and we chose transmission electron microscopy to learn about the surface properties of our nanoparticles, and Fourier transform infrared spectroscopy for size distribution, and shape, which are important parameters when synthesizing these particles. Now we can start our in vitro analysis, but first of all, I will present a little about transmission electron microscopy. We actually had a very interesting course about that while working on this project 1 year ago. It has a high spatial resolution. It allows for a direct measurement of size and shape. Yet we need ultra-thin samples and a quite expensive equipment. Here you have the procedure. We dry the colloid and we inspect it in a high vacuum chamber. And there are sometimes formed nanoparticle aggregates. There are still solutions for keeping an unaltered suspension. We use this bovine serum albumin, for example. There are a lot of methods, and we had an opportunity to read about them. Here you have different images, how a transmission electron microscopy experiment result would look like. Because we were online, we had to rely on this kind of images because we couldn't perform the experiments ourselves. Now we also used Fourier transform infrared spectroscopy, which is a interesting method that got us information about the chemical composition of nanoparticles and coatings by using some resonant modes within the covalent bonds and when exposed to infrared light. Then we use a Fourier analysis, a mathematical method, to identify in this spectrum the wave numbers we are interested in. We also relied on a thermal characterization of our nanoparticle because when we transmit heat, we want to adjust the specific absorption rate by external means. And we use nanoparticles in slightly mineralized water, a closed container to minimize evaporation, and at 37 degrees Celsius, because this is the temperature close to human body temperature. And we investigated the dependence of this SAR to the frequency of the magnetic field applied. We obtain a linear dependence on amplitude and a quadratic dependence on frequency. Now, because we want to prepare those particles for in vivo experiments, we must be very careful to the risk involved. High concentrations can be toxic. We have to make sure that our organs are prepared to take this quantity of nanoparticles, and we have to mitigate the risk by maintaining the concentration at a small level. We also have to give the nanoparticles the capacity to disintegrate and participate in our biological processes, and this can be done by a good choice of coating. Now, Alexander will present you the conclusion.
Okay, thank you. As conclusion of this project, after many classes about nanoparticles, so we choose metallic nanoparticles. We have explored one of the many promising perspectives regarding the use of metallic nanoparticles in biomedical applications. However, there are still many uncovered aspects and possibilities, which will be probably known and explored in the maybe close future and maybe for 20 or 30 years, especially in a nano world. This may be said uncovered by this could be uncovered by next experiment and generation, and also by future experiments with new coatings, new shapes, and also especially in vivo environment. So that's all of this conclusion. Thanks for your attention.
And we would also like to thank you for this opportunity to participate in this truly interesting project.
You're welcome.
You're welcome. And thank you for your presentations. So now it's my turn, yes. to share a screen and present. Where is share screen? Share. So do you now you say yes?
It's dark and okay, now it's okay, but it is not in presentation mood. Yes, presentation way.
stop the share. Let's start again. It's not my day today. It's really not my day today.
No, don't say so, Karin. Everything is going. Don't worry.
Oh, no, I'm usually not so helpless. I usually don't need help, but right now I can't share. It doesn't react actually. Close? No, I closed.
Okay, we wait you.
So please. But you still see my presentation, yeah, mode, not my presentation mode.
No, we see yourself, you.
Yes, I know, I understand that, but but it's it doesn't give me any other way right now.
You don't see the green button on the bottom.
Yes, I use the green button.
Okay.
Sometimes F5 doesn't work in Zoom. I faced with this program once. Try to use slideshow.
I tried to. I wanted to use the slideshow, but it doesn't allow me. Just to be quick and not waste your time, our time actually. You can. I will be very quick and don't change anymore this. No. So I have to start with. Do you see now something? No.
But we saw before your presentation, just maybe not in the full size variant, but we saw. Do what you did before.
I can't remember anymore what I did before. Share once more.
Yeah, we can see.
Okay.
It's okay.
Students in our Taltex lab, we also, I have to start with that, we had pre-corona time and this is present time. And actually one big change we also had in this 3 years, let's say 4 years, because the building up the project took also almost a year. So right now, when we started, mining and oil shale was in Estonia very big part of economy. It was 4 years ago, and now we are in the time where we are stepping out of the oil shale mining. It will stay in general, in somehow in chemistry, but not in energy anymore. So the first program what my colleagues put together was about oil shale and mining and extracting and all the product raw materials and projects related to our mineral resources, and mainly oil shale. The program itself was 5-day internship. Students were supposed to do different experiments in our mineral resources labs and have a visit in underground, and also had a video concourse and summary of our program what they had here. So in first year 2019 we had 3 students from Ukraine. It was very interesting to see other school students in our activities, because we used to have Estonians here, and we know how they react in different situations. So young Ukrainian students were very happy to have them here, and they were very interested and wanted to learn and see more than we actually could give them. So I hope they were happy too in their own countries later. I haven't seen them, and actually all the instructors from this first program and the second programs are right now busy with other tasks, so they can't give a detailed overview. But here you can see the pictures of, on different activities, and actually the most important, interesting discovery for ourselves. They visited also the powder metallurgy lab and could weld things together. So, and girls were more excited about the possibility than boys. So it was a very interesting for us to see and hear, and it didn't matter actually, Estonians or the visitors from Ukraine. The result was the same. It was much more interesting for girls than for boys. It's what that was for us the discovery part, what we didn't expect. And on the right side you can see the visitors, and the left you can see actually Estonian members. We had the seven members group from Estonia also. I think the Estonians visited us later than students from Ukraine. And then came Corona and the change in raw material sector in Estonia, and we had to change it a little bit in a point of view of circular economy. And we added topics where we can actually agree. No, what's the word? Particles of rocks in plastic. It's very simple, wrongly said, but I can't right now get the term in English. For students it was just for local students, because it was COVID time and we couldn't have big groups or foreign students here in Estonia. The last pictures are from this year's August, and they worked in our labs, and the reporting is still going on. But again, for girls, for the topic more interesting, excited than for boys. In general, I think the idea itself, the idea of this project is very interesting and very useful to see what's actually going on in this field in the industry. It doesn't matter that you have to go to one big factory or plant. You can actually do some work, real work in universities. And it's not about just getting linked with the university, but you can actually have a part of the research, because in our general research papers, the students will have their own research ideas, and they will be supervised by university instructors. But in this case, they can be part of the much more bigger project. It gives them the understanding that they will be in part of the research or the industry project, real doing. This is the value of our side, because we have students here almost all the time doing different workshops and courses. But in every class and every student group cannot visit every lab what we have, because of the not enough knowledge, and sometimes the groups are too big and not so interested. They're just wanting to see what it is, but not working in it. So that's the value of this project for us in my side. So if there is no other question, then I will give my word to Tanya, and stop sharing my screen.
Thank you. Now I will try to share my screen. Can you see, please, my screen?
It's okay, perfect.
It's okay, yeah.
Thank you. Thank you very much. Dear coordinator, dear partners and guests, at first I would like to thank you a lot for the opportunity to take part in the project Raw Materials, Students' Internships in East Southeast Europe. This project was a great advantage for the biggest scientific institution in Bulgaria, which is Bulgarian Academy of Science, because it was a real bridge to the secondary schools. During the project implementation, we shared our experience in the field of the sustainable environmental protection via effective utilization of the raw materials, novel approaches to waste management, and development of original strategies for alternative clean energy supply. The activity of the Institute of Organic Chemistry with Center of Phytochemistry was strongly related to the main subjects of the project directed to the recycling and material chain optimization for end-of-life products. The students were educated in the field of the biomass as a source of the production of energy and valuable functional materials with impact to the circular economy, with the potential to the preparation of biofuels, catalysts, and adsorbents. Also, the progress of the nanotechnology and advanced materials, in particular preparation of carbon nanomaterials, mesoporous metal oxides, smart molecular machines were also in the scope of the education. The accent on the hydrogen economy based on the cleanest and the most efficient energy vector and advanced technologies for the air and water purification were also in the scope. During the RAISESEE project implementation, 5 contracts between the Institute of Organic Chemistry and 4 secondary schools in Sofia were done. Each of these contracts was accompanied with a particular program for the education of the students, which included lecture courses, experimental work, visit to industrial plants, students' presentations and competition, dissemination of the RAISESEE results. During the project, 2 lecture courses for the students from 4 secondary schools were organized. The first course, which was held in 2019, was carried out in presence, and it was attended by more than 20 students. The second course, because of the COVID pandemic situation, was organized in November-December 2020 using online platform. Nevertheless, this course was attended by more than 35 students. During these lecture courses, the leading scientists from the Institute gave 11 45-minute long lectures, which topics were directed to the advanced carbon and metal oxide materials and the main problems related to the clean energy supply and sustainable environmental protection. Also, particular accent was given on some additional skills in the field of how to work in the chemical laboratory safety and how to prepare my presentation. Very important accent in the students' education was the experimental activity in the labs of Institute of Organic Chemistry. 15 students were educated experimentally. They were divided in 4 groups. Each of these groups separately fulfilled a particular program, which included short introductory lectures in the field of the current experimental topic directed to the preparation of activated carbons, characterization of the specific surface area of activated carbons by iodide number, characterization of surface acidic groups of the activated carbons by titration with different basic compounds, catalyst preparation and related stoichiometric calculations, basic concepts in catalysis, methanol decomposition as a source of hydrogen, UV-Vis and FTR spectroscopy, and GC analysis. The students from the 4 groups prepared activated carbons from different agriculture residues, such as walnut shells, cherry stones, mixture of walnut shells and cherry stones, and mixture of sawdust, which was residue from the wood pellets production, and polymer waste. Further, under the guidance of the students, of the scientists from the Institute, the students did experiments related to the elucidation of the texture of the activated carbons by iodide number and characterization of the surface functionality by titration with different bases, as well as by using FTR-Kaber technique. The obtained activated carbons from different wastes were loaded with zinc ferrite using impregnation technique in order to prepare catalysts. The students obtained knowledge and hand-working experience for the catalytic apparatus and GC analysis. They obtained catalytic data for the methanol decomposition to hydrogen and carbon monoxide on the catalysts which were synthesized by them. In addition, they did experiments for the water purification from dyes using methylene blue as a prop molecule by adsorption on the activated carbons which they already prepared from different wastes. Here, they obtained knowledge and hand-working experience for the UV-Vis technique. During the experimental work, special attention was paid on the processing of the obtained results. The students were educated and controlled, preparing their protocols from the experiments. Very important part of the education was the two visits, which were organized to the industrial plants. The students visited the industrial company Sofia Met, which activity is related to the copper and copper alloys processing, as well as the industrial plant BA Glass, which activity is directed to the glass processing. In the final of the education, the students prepared alone 3 projects aimed to the potential of the hydrogen, activated carbon application, and environmental protection. A competition with their presentations was organized in presence, and the best presentation was awarded. The dissemination of the RAISESEE results was done in two distinct lines. The students prepared 3 posters, presentations, which included all results from their education in the labs of Institute of Organic Chemistry. The posters were prepared under the control and education from the scientists. At last, the students defended their posters and discussed their results with many scientists from during the Jubilee session, which was held in April 2019 in the Institute. Besides, the aims of the RAISESEE project and the related news were regularly announced in the information letters to the Ministry of Education, Regulation Department of the Education, and many secondary schools in Sofia via short notes in the electron media website of the Institute, by presentation in the Institute conference, and on the site of the Regional Department of the Education. At last, again, I would like to thank the coordinator of the project, to the directors of the schools and the teachers from the schools for their support, also to all my colleagues who take part in this project, and thank you for your attention.
Thank you, Tanya, for your presentation. And Katarina, are you here?
Yes, I'm here.
Good.
Just a moment, colleagues. Yes, hello again.
Hello.
I try to decrease the loading on my internet. That's why I change your connection. Hello, dear colleagues. Dniprotech today joins to the conference. We'll share our experience under our projects involved under RAISESEE, and I hope that, except of me, Professor Zveshkova today will share some the most interesting moments from her experience of participation in this project, and of course our Yeva Tsipko, our alumni, who joined to us today, and as well her main goal will be to say us what was the main interest in the most exciting in this project for her and for her maybe near future. So let me to share my screen. Great, so I hope that you can see it. And yeah, can you see?
Yes.
Everything. Okay, so I would like to tell about our basic activities, about that experience that we gained, and about our outcomes of our students, from our point of view. And I hope that Yeva will join later and say her opinion about what I will show to you and about her own experience. So firstly, I would like to show where we are, because unfortunately, because of COVID situation, unfortunately, nobody couldn't join us, couldn't reach us and realize activities that we planned. I mean, international pupils and students from other countries. But maybe next time in next project we will welcome So what activities, what we did on the RAISESEE project in Dniprotech, what main tasks were realized. So the first thing that it was the main thing for all our participants in our consortium, that is a recruitment of pupils and technical school students to participate in our project internships, in our project activities. The first main thing was the organization work, because we would need to create a team inside our university, because here at every meeting that we organized, you saw me and Professor Olena, but behind our shelters, of course, we had a team of lecturers. We joined them to some activities to give our students the best experience in plant areas activities. That is why we worked with partner departments and, of course, industrial partners to organize these internships and different internships formats. And of course, after we would need to implement international internships. And in our case, we sent one student, and Karin mentioned. Yes, it was really very lucky experience, and we like Taltech very much. I hope that someday we'll come to you as well and we'll see your labs.
You are welcome.
Thank you. And after COVID restrictions, after 2019, 2021, years must be spent on local internships. And our 5 students were awarded by local internships prizes, and we worked with industrial partners in our departments to organize activities for them. And yes, the total number was 5 students. So generally we realized work for 6 students, and 6 students received grants, and we have 6 alumni under RAISESEE project. So I would like to mention our Dniprotech's team. Except of me, I represent here the International Academic Mobility and International Projects Office and Department of Construction, Geotechnics and Geomechanics. And of course, our main scientific coordinator and ideas generator, Professor Olena Zdeshkova. She represents the Department of Higher Mathematics. And we attracted to our activities a list of different departments of our university. They are the following: Department of General and Structural Geology, Department of Chemistry, of Surface Mining, Engineering and Design of Machinery Industry, and Department of Ecology and Environmental Protection Technologies. Because they had different contacts with different industrial partners, and our common work actually allowed us to organize everything and actually reach that outcomes that I will mention close to the finish of my presentation. Among our industrial partners, you can see some mining enterprises, especially mines like Padatech Pavlograd Vuyilya, mining company, Ferexpo Poltava Mining, well known in Europe, Pavlograd Chemical Plant, Zat Anatems, Quartzit DM, and Marganets Mining and Processing Plant. We have cooperation agreements with them, and we had and still have our contact persons, that professional specialists who were glad to work and share their experience to our students and our pupils. Moreover, of course, how much schools and technical schools were involved in the project. That is about seven educational units: Ukrainian and American Lyceum, Kamensk State Energy Technical School, Financial and Economic Lyceum, and 4 general educational schools of our city and suburbs. Yes, that is the first activity, and Karin demonstrated it as well, experience of our and girls. So it was really excited, and I know that after the first dissemination at one event organized by our national contact point of Horizon program, when we disseminated this first activity, I remember that lecturers, a lot of moms and different parents, they came to us and asked that what is a very interesting activity. Is it available at other schools of our city? So they were very impressed that does general schools guy received the opportunity to visit international university, to be abroad and participated in laboratory works. That's why that is a really very great experience for our city, for our pupils, I mean, of our city. So, and after COVID happened, and we needed to do something home. And here a list of projects were born devoted to raw materials sector particularly, because we have a list of different plants, I mean mining and processing plants, careers, who were welcome actually to receive our students. Our departments opened their doors to demonstrate how we work, how our lecturers teach, how we work in lab, on practical classes, and we organized all our projects in 2021 in the following way. We gave students some lecture materials, like preparation before some activities on plants. So, and here you can see our next alumni, Eva Tsipko, Diana Rudkova, and Bogdan Kurilenko. They had lectures and in geology, and they received the opportunity to know how our theoretical lectures work in the university, so how students live and study. They had some lectures at chemistry department, and also lab workers demonstrate what they actually do with students in everyday life, in their scientific work as well. They participated in some experiments by their own hands, so that was very interesting for them. And after receiving this base, they were ready actually to go to some enterprise to participate in some enterprise activities. Another department of engineering and design in machinery industry demonstrated the experience of work with virtual reality facilities, and they so allowed to test everything, to touch, to show at their real experiments and their real work with industrial partner Anna Thames. On this photo you can see Alexander Yegurnov, our industrial partner. I hope that tomorrow he will join to us and also will tell about some results. And after Anna Thames welcomed actually, and they shared their experience on their work of the creation. The head of this actually a big company, again, Alexander Yegornov, participated personally, forgot about his daily routine work. And spend time for our students and involved them in documentations and all tests, allowed to do for them a lot. We saw their the industrial site, and it was really it was great to see, to work with them, and students were really excited, especially here. Girls under their project, they visited their labs, and I know that today I think that Eva will share information, her experience, and how she worked with this company now being a student. Again, that is Department of Surface Mining as well, demonstrating the processes realized at Poltava Mining, Expo Poltava Mining, because they work very actively with this enterprise. They explained before what is happening at this enterprise at Poltava, at mining and processing enterprise, and after our students will be able to see everything by their own eyes. That was really an exciting experience, because that is you can see on the photo, that is a really very big practical experience for students, because they haven't never seen this in real life. Main technologists, some managers, they were involved when we visited this enterprise. They explain how it works, what skills are required to work there, what is a list of daily routine works point, and so on. Here you can see some materials that we took from Bogdan Kurilenko's project, which is called Compel. And after that was realized at the end of 2020, and after 2021, we continue some activities from the previous year. So we continue lectures and laboratory works at our university on the Compel project, and we planned even joint scientific publications and participation in conference with girls and Bogdan, and also continuation the work with Anna Thames. And of course, we planned activities of which were realized this year, some weeks ago, and last Friday with new pupils and new mining and processing plants. Bogdan was participated in scientific work, real scientific work in our lab at our department, and he is still continuing. And he changed his mind, because he was really impressed by this experience, and he decided to come to us. And actually, I think that that is the main outcome of the project, because the student was extremely motivated, and he chosen to continue to work and to build his career, especially in raw materials and civil engineering area. Now he is our student, first-year student. He participated in scientific conference. We disseminated our results under RAISESEE, and Bogdan even took one of the prizes. And this year activities, very active activities, in this November at Quartzite Mining Enterprise, Quartzidem. They were realized 2 weeks ago, the first with Alexander Belyaev and Oleg Shevchenko. And another activities and Marganets Mining and Processing Plant in Marganet City. We were there last Friday. Main technologists worked with us a lot, and students received the opportunity to understand what is the real heart, sometimes work of geologists and main technologists who work in Korea, but they work with very interesting things. So, and we planned maybe some continuation of these last activities, maybe in this month, maybe even later, the beginning of 2022. But we have already have main outcomes, and I would like to clarify. I would like to highlight them. You can see them on the slides. Of course, RAISESEE is a unique project for our universities because that is a great practical preparation of our pupils. Doesn't matter they go to other universities, but practical preparation is really unique. Increased motivation. First career steps, they started to think about what they want, where they want to work. Ambitious plans for future. They want more acquaintance with the specialty and employers, development of study programs by lecturers. That is the outcome for us, because we want to make our programs better, and of course our pupils become our students. I think that is the main. And Yeva, please, the floor is yours. Some main points. What was the greatest for you according to your experience in the project, please?
Okay, good afternoon everyone. I'm Eva, and I want to share with my experience, because after the meeting with Alexander Yegornov, we have managed to have some conversations while doing the flotation experiments. And during this conversation, he suggested me to join their company to become a co-worker of the Anatem's company. I was really excited, and 1 month after the RAISESEE program, he phoned me and invited me to become a laboratory worker in his laboratory, and also to work with some communications issues. So I've joined his company and worked here for 8 months, which is really good for me. And this experience was like mind-blowing, because I'm the 16 years old is working in the laboratory after the RAISESEE program, which I couldn't imagine a year ago, for example. Also, I've gained a lot of experience doing the flotation processes. I've been also working with the university literature about the flotation. And although I've met a lot of new people in science sphere, which is also good for me. And all I want to say, this experience in RAISESEE program, not only about the new knowledge which we are gaining, but also that is about the fact that we get a lot of new experience. Like we are into this theme, we're seeing the enterprises connected with scientific and the mining sphere, and that is really good. I want to encourage students to take part in this program. That's it.
Thank you. Thank you. That was the contribution from us. If you have a question, we'll be glad to answer. If no, I close the sharing.
Thank you, Katerina and Eva. And in my calendar, next should be Victor.
Yes, thank you.
Hello.
Very nice. Hello.
Hello.
It's very nice to see you.
You will be the last one before coffee break, so.
Yeah. I'll try to be short.
No, it's okay. Take your time. It has been very interesting here to listen everybody.
Okay. Do you see the slides? Please, do you see the slides?
Yes.
Yeah. Okay. So I will try now to share on my experience and also on the experience of our students at the National Institute of Materials Physics. And I will start by underlining some specificities of the training here. I mean, in our institute, we have some alternative events as the researcher night or the very short summer schools, where the students also from the high school could perform a short hands-on training and simple experiments. So our target related to this RAISESEE project was a little bit different. I mean, our target was the stress on the implication of the research activities on issues related to raw materials. That means to try to share our knowledge concerning not only the circular economy, but especially on how to save critical raw materials by increasing the efficiency or decreasing the size of some effective functional system. That means our intention was to present some such kind of effective functional systems and to present the principle and the physical principle on how they work, on how to increase their efficiency or decrease the size or how to focus the consumption of the energy in very small areas. So that was our target, was a target especially related to research, scientific research issues, and therefore we have chosen a somehow different strategy related to our internships. Our strategy was to choose some representatives among the highest educated students for this type of specific training. And we had in mind that if we can share to these very high educated students from high school our experience and knowledge, there will be very effectively that they in turn, they will transfer this knowledge to their colleagues. I mean, instead of trying to train a lot of students, let's say, we have considered it's better to train a very few, low number of students, choosing the most suitable for that. And therefore, as a consequence of this strategy, we have applied a selection also for the local internship. And this selection was done based on well-defined application. And I will say that also a consequence of this selection that we have done, the way for sending the national students to the international internships was also very effective. I mean, we had a lot of students interested for applying for international internship in the RAISESEE project, as also Vladimir can confirm that. Again, going on, in order to do this selection, we have chosen two ways. We have contacted directly two of the best high schools in Bucharest. That's the International High School of Computer Science and Tudor Vianu High School of Computer Science. But also we have tried to post on the Institute site the announcement about the RAISESEE project and in what consists the application. It was this experience that we feel that we have, that if you put some barriers, I mean, if you try to have a selection of the students, they will come, especially the most interested one, and we consider that this is the most effective way in sharing our knowledge. And now, as a consequence of this strategy, I want to thank Dr. Ioana Stoica, which is physics teacher at the Tudor Vianu National High School of Computer Science. She was extremely interested. I mean, we had the best connection with her. She was very interested in this project. He advertised among the students. She helped the students for doing right applications, and I'm really very in debt to him because I consider that it was a key person for the success of the project in our institute. Okay. Now, concerning the planning activities, I should say that we started from the beginning with some planned activities, but all the time during the project, this was reconsidered depending on the interest of the students that we had in the previous year. And I want to stress a few type of activities which I consider very interesting. So we considered to give an introduction to the main high technological application, which requires critical raw materials, and to have free discussion on the scientific support for the use in such application. I told you to explain the phenomena and so on, and to see how the students imagine that the things could be improved in these respects. And also to have an introduction in the type of waste and waste roadmap, and that was focused on recycling of used battery and recovery of plastic and noble metals. And also, especially, we were focused on the driven reasoning for possible replacement in high technological and industrial application of the critical raw materials. And I told you, we tried to explain the functionality of the devices, and then to show the principle that can lead to such replacement. And the focus here were on, especially on two aspects. I mean, in catalyzers, how the noble metal can be replaced, and also in permanent magnets, how the rare earths can be replaced, especially considering a new physical phenomena which can increase the energy product ratio. Then, accepting this theoretical aspect, of course, we have done with the students the experimental work. The experimental work was focused on the two type of aspects that I just mentioned before. And I'll say that also we have changed in the last year related to the part of nanoparticles and the application of magnetic nanoparticles. We have tried to go to switch towards magnetic hyperthermia process with magnetic nanoparticles, because we have seen that the students are really interested in the physics of such phenomena. Of course, at the end, there were also some additional activities. That means there are visits at the institute facilities and also short visits at the industrial collaborators of the National Institute of Materials Physics. And now, very short, we started, as I told you, our intention was not to train too many students. We had two students for local internship, of course, in 2019. It was only one student in 2020 due to the pandemic conditions, in spite of the fact that the, let's say, the interest of the students was continuously increased at that time. I mean, there were many applications from Tudor Vianu for doing such kind of local internship, but we wouldn't able to do that. And also in the last year, I mean, in this year, there were more than 10 applications. We have forced to keep only 6 of the application. And as you will see also, this number of 6 applications seems to be too high because it was not enough time to do the practical, I mean, the experiment, different experiment, because we do different experiment with each of the students. We don't perform the similar experiment with all of them. So it was not the right number, as you see on the witness that they have considered at that time. I also want to say that after doing this training period, it was not, the interest was not the usual report that we should send for the RAISESEE project, but it was a way to check on how the students got a specific language, how they try to understand the quite complicated things that we explain, to see how they can expose in their own terms and what idea that will have to improve the things, as I told that. And just I briefly read some opinion of the students about this training, and also I will try to insist more on the strength, weakness, and the SWOT diagram of the students. And of course, I have shared in 2 categories. One is the pre-pandemic, I mean in 2019, and I choose also an example for 221. So it's clear that the students were quite satisfied with this kind of internship. They had the possibility to work in real life, in a laboratory, and all of the students have mentioned, I mean, also from 2019 and 21, they have mentioned the importance of this internship on their further career. In fact, here, it's Andrei Koman told that it's clear that this experience influenced your decision in choosing a further job as a researcher. Among the strengths of our activity is the possibility to work with high-level experimental setup with qualified project coordinator, and also on the fact that they were focused on independent work. As a weakness, it was a busy schedule of the project coordinators. I mean, we were many persons doing the practice with them, but the usual duties didn't allow us to stay all the time with the students about the opportunities, again, the real research experience, and the way that they understood how to choose the experimental setups to see and to look for the more specific phenomena in the functionality of the devices, and how is the way and the methodology for improving a specific material in respect to saving energy, saving volume, and so on and so on. As threats, all the students were afraid that they could do some damage of the instruments. There is also the report from the students from 2021, and I want to stress here, so there are more or less similar aspects. They were very pleased to use the scientific equipment, but I want to causing a short-term lack in in-depth assimilation of knowledge. So the main problem is that the internships in 2019 were for 2 weeks, whereas the internship in 2021, again due to the pandemic conditions, were for 1 week. And that associated with the fact that we had 6 students instead of 2, 3, lead to this, let's say, shortcoming from them. They felt that that the training period and the information was too large for having a good assimilation. And again, the same threats, they were afraid to make some faults of the equipment. What I want to say that we have considered this opportunity of the RAISESEE project to discuss more about their career. Also because it was an European project, and our aim is to try to convince them that there are a lot of possibility for doing research or for doing good jobs in their own countries, or at least in the European countries. I told you there are about among the best students and among the Olympics that we have. And what I would say that after such discussion, they agree that there are a lot of opportunities for doing research here, also in Romania and also in this institute. They were convinced that they should do a career in research, but they were not convinced that they should remain in Europe. We had some follow-up. I mean, we kept the connection with the students. And for example, one of the students from the first year, who is Andrei Coman, he is already in the California Institute of Technology. He applied for research stages there, and he asked us for recommendation letter saying that indeed he worked in a laboratory, in a research laboratory, and he already done such kind of training. And I think that it's time to stop here. There would be also many things to say. Just to say many thanks to my colleagues having in charge the training of the students, are Dr. Cezar Comănescu, Bogdana Borca, Anda Stanju, Gabriel Scânteie, Petru Palade, Petru Bădică, and Claudiu Lucovei. And thank you very much for your attention. And please, if there are questions, I'm pleased to answer you.
Thank you, Victor, for your presentation. I think there are no questions. Now it's time to coffee break and stretch your legs, and we start in 15 minutes. Is it okay for you all? I see some heads are nodding, and then yes, I will take this. yes, and I will stop right now recording and start over when we see each other again in 15 minutes. Okay. And then Kaisu, you are the first one to present.
Yes, I'm ready.
Good, thank you. So see you soon.
See you soon.
See you.